Welcome to this Maths Heroes video. My name's Christine. You can see a screenshot here of a game in progress. And here you can see that my last move was to move my piece to D6. D6 happens to be, the letters are across the bottom here as A, B, C, D. So I'm actually going here in this column. And then I'm in 6, which is, let's have a look. B6, well, it actually starts at the top and goes 1, 2, 3, 4, 5, 6. So I'm coming in here. So this is actually the reference that I'm doing. I've also got here a screenshot from Excel, and you can see here that it says I'm in cell C4. So that's I'm going to cross the columns to C and then down the rows to 4 to be in cell C4. So this video is about how could you encourage your students to think flexibly. And one of the stories that I heard was, so in Australia, we have a lot of cattle mustering using helicopters. So it's just a story you could tell your students. But while the pilot was flying over, he noticed some haystacks in one of the properties. And as he flew, and so he flew from the bottom of the screen to the top of the screen, as he flew up, so that pink arrow, he said, oh, I can see I've got 6 and I've got 2. So he reported back 2 rows of 6 seen in the haystacks. He turned around and started to fly back to base. And as he flew back in from the left-hand side, he said, oh, I made a mistake. And he actually counted 2, 4, 6, 8, 10, 12. He actually counted 6 rows of 2. And so by this stage, your students should be saying, no, it doesn't matter. 2 rows of 6, 6 rows of 2, the amount is still the same. So the amount is the same or equivalent, whatever you want to use. The equivalent's better. So 6 tablets for 2 days is taking the same number of tablets as 2 tablets for 6 days, but obviously the effects would be very, very different. But we're not looking at that at this point in time. What we're trying to do is to have our students be flexible in their thinking and not locked into 2 rows of 6, and this is the only way I can see it. I've got some examples there of my multiplicative thinking blocks. You can rotate them, you can flip them. You can say that they're 3 4s, you can say that they're 4 3s. It doesn't matter. So I work with a little 10, 11-year-old girl. I've been working with her for 6 weeks, half an hour a week. And so she actually is unable to count consecutively to up to 10 without error every time. But we needed to move on from friends of 10. So I thought, okay, let's have a look and we'll start doing multiplication just with small numbers. And she had 2 10-sided dice. She gave them a roll and she first rolled 7 sevens. And I gave her the choice. I said, you're welcome to take 7 sevens or we can roll again. And she thought about it and she said, roll again. And she actually rolled 2 3s. And the second one she did was 2 4s. So I've recreated it here, but she actually did all of the pattern block placing and so on. So she actually created 2 stacks of 3 and then moved that other one from each stack to make 3 stacks of 2. So for me, this is the do part before I get her into making arrays. And you can see over here that she actually struggled to write 2 multiplied by 4 equals 8. And we spoke about, I said, do you know what this symbol means? And she said, and she put 2 fingers up, she put 4 fingers up, she counted them, she said that's 6. I said, do you know this symbol? And we looked at the multiplication symbol and she said, oh yeah, I remember that. And so then she rewrote it as 4 groups of 2 equals 8. We did a few examples. So the last one I had the chance to do with her was She rolled a 5 and a 9. And I said, "Would you like to do 9 fives, 5 nines?" And she said, "Yes." So I said, "Okay, let's have a go at that." So when I was a kid, I used to get 20 cents pocket money a fortnight. So I had these stacks of 20-cent pieces. I would take a tower of them. I would count out 5, and then I would basically just make the stacks the same size so that I didn't have to count out every single one. When we give our students discrete objects, their tendency is to show us how well they can count, and they count by ones, and they never move past it hardly, or it's difficult to move past it. So she actually made 5 stacks of 9, and I instead of her letting her count each one, I actually helped her grab a whole stack, and then we made them equal. So we looked at the top of the stack. It's a bit hard to see from bird's eye view, but we then said, "Okay, how many do we need to take off each stack?" So we took off 4 because she'd actually had 9 fingers up. I said, "Well, put down how many you need to have only 5." And so she put down her 4. So she said, "Right, we're going to take off 4 from each stack." We took off 4 from those first 4 stacks. And then we took that last group of 4 and we gave 1 to each of the other groups. So now each group has 5 in each stack. So that went from 5 groups of 9 to 9 groups of 5. And you can see the working out that we did over here on the whiteboard. And she wrote down 5 nines, didn't know what that was because we hadn't counted how many that was. We said we're going to look for 9 fives because she could count by 5. She's 5, 10, 15, 20, 25, 30, 35, 40, 45. So she wrote down 9 multiplied by 5, and she sat there and she said, 45. How do I write 45? I thought, oh, I didn't say anything and I let her go, and she wrote down 45 here. So I know I've still got some work to do with that. She was so proud of herself for being able to do that, and her brain. It was absolutely wonderful. So it's absolutely not perfect yet, but it's a great way to start. So I've used the structure of a 10 frame to do that. We used a dice to roll, and we're going to do more of it. But this is the do part before the arrays so that she can actually physically manipulate those objects without counting every single one. If you've got some feedback, please feel free to let me know. Love to hear it. And thanks for watching, and I'll see you at the next video. Bye for now.